Now, let's talk about how things actually happen on Soroban, how operations work, how transactions are structured, and how contracts are authorized and invoked. Operations are the fundamental building blocks of transactions on Stellar. An operation is an individual command that modifies the ledger. Think of operations as atomic actions. Each one does a specific thing. Operations can perform functions like sending payments, creating accounts, or invoking smart contract functions. Each operation type has its parameters and effects on the ledger. Example of operations include payment op, create account op, change trust op, and invoke host function op. The last one, invoke host function op, is particularly important for Soroban because it's how you trigger smart contract execution. Now, let's understand how operations are packaged into a transaction. A stellar transaction consists of a source account, the account from which the transaction originates, a sequence number, which ensures transactions are processed in the correct order, and then a list of operations, which can be multiple operations in one transaction, and finally, an optional memo, which is an additional information like a reference number or message. The source account initiates the transactions and signs it to authorize the included operations. The sequence number is crucial for preventing replay attacks and ensuring ordered execution. So now, probably asking, why does multiple operation matter? Here's something powerful. A transaction can include multiple operations, allowing complex multi-step processes to be executed within a single transaction. This is atomic. Either all operations succeed or they all fail together. For example, you might create a transaction that does three of these: transfer funds from your account to a contract, invoke a contract function to stake those funds, and then records the staking transactions in a separate contract for tracking. All three operations execute atomically. If any step fails, the entire transaction rolls back. The transaction envelope bundles all part of a transaction so that they're transmitted and processed as a single unit. It contains the source account, sequence number, list of operation, and optional memo and required signatures. After execution, transaction metadata provides detailed information about what happened. It includes operation result, ledger state changes, and any generated event logs. This data is useful for tracking, indexing, and analyzing contract interaction. So let's talk about threshold and signature weight. This is where Stellar security models get sophisticated. Operation falls into three thresholds. The category are low, medium, and high. And has a weight between 0 and 255. For a transaction to be accepted, the total transaction weight must meet the required threshold. This enables multi signature authorization where multiple parties must approve a transaction. For example, a high threshold operation might require signatures from 3 out of 5 authorized signers, each with a weight of 50, totaling 150 to meet the threshold of 100. So now, before a smart contract function runs, the transaction must be properly authorized. The network verifies signatures and ensures the required threshold level are satisfied. Only transactions that meet these authorization rules can proceed. This multi-layered authorization system provides flexibility. You can set it up as single signature account for simple operation, multi-signature account for shared control, weighted signatures with some signers have more authority or different threshold for different operation type. Invoking smart contract function. After authorization, smart contract functions are triggered using an invoke host function op. This operation specifies the contract address and the exact function to execute along with its input parameters. Think of this as calling a function in any programming language except this function lives on the blockchain. Validation and execution. So once a transaction is submitted, the Stellar network checks that the transaction and its operations comply with protocol rules. If valid, the smart contract executes within a secure and isolated runtime environment, ensuring safety and determinism. This ensures all nodes execute the contract identically and produce the same result, which is essential for consensus.